Alright, so we looked at an introduction to what a process is. We now take the discussion forward by discussing process states. So a process, as you know, is a task, and forget about computer tasks or processes for a second and just look at a task in the generic sense of the word. A task which you have to do, a task which is on your to-do list, so to speak. It can be in different states, right? You might have just put that task down on your to-do list. You might be halfway done. You might be waiting for someone else's inputs, or something might have come up because of which you have put that task temporarily on hold, or maybe the task has been completed and it just needs to be struck off your bucket list. So these are different states in which a task you have to do can exist, right? So the same logic extends to tasks in the context of a computer as well. So a process can have 5 main states: new, where it has just been created; running, where it is being executed; waiting, where it is waiting for some resource or some event, for example input output; ready, where it is ready for execution. It has to be assigned to a CPU. So if you remember, we looked at scheduling as one of the tasks of an OS. So a process is ready, it is waiting to be executed. Whatever resources it requires, everything is available. There is a CPU, so the OS has to pick up this task and deliver it to the CPU and say, you do this. So when it's waiting for that assignment to happen, we say it is in the ready state. Terminated, of course, means the process has finished execution. So we will look at this diagram a little bit. So initially, if you see, when a process has just been created, it is in the new state. It is then admitted to the ready state. So admitted, what it means is, a process has been created. You need to run a quick check. You need to see what this process needs, what kind of resources it needs. Does it need any input output? Does it need computation? Is there any process on which this is dependent? Like, is there a process which needs to be finished before this can be started? You need to do that quick audit, make sure everything is clear on that front, and once everything is clear, we put it in something called the ready queue. We will be talking about these queues in a minute. So it is in the ready state. Then once the scheduling happens, scheduler dispatch again means the OS is going to take the process and allocate it to one of the CPUs and ask the CPU to start working. Once that is done, it is in the ready state, in the running state, I'm sorry. Once it is in the running state, it is running, and then supposing while the process is running, you realize that some input output is required, or some other sort of dependency has been realized when the process is in the execution state. It will be temporarily suspended and put into the waiting state until that dependency is fulfilled, that input output event or whatever needs to be done is done. Once it has been finished, it will go to the ready state, not back to the running state. So this again is something, it's a small caveat sort of a thing to keep in mind. So the process was running, and then we realized there is some dependency, so we put it in the waiting state. That dependency is being fulfilled, some work is happening on that front. In the meantime, the OS does not want the CPU to sit idle, so it will take some other process which is ready and put it in the running state. So some other process is running now. This process which was in the waiting state has completed its dependency, it is now ready to be running. It will go back to the ready queue and it will wait for the scheduler or the scheduling part of the OS to assign it to a CPU. It cannot directly walk back to the CPU and ask to be executed, because the OS is the only authority who has the power to tell the processor which process to execute at what time. So yeah, once the dependency is fulfilled, it goes to the ready state. Again, the scheduler will send it here, it will run. Similarly, instead of a dependency, if there is an interrupt again is something you all are familiar with by now. If there is an interrupt, it will again go back to the ready state. The interrupt will be serviced, and then again it will wait to be scheduled. It will get scheduled, it will be running. Once the process has been successfully executed, it is pushed out of the queue and it is said to be terminated. So this is the life cycle of a process. I will give a quick recap. When it has just been created, it is in the new state. We run a quick check of dependencies and so on and so forth and admit it to the ready state. Whenever a process is in the ready state, a scheduler or the OS, the scheduling part of the OS has to pick the process up and give it to a CPU or a processor, and then it goes to the running state. If there is an interrupt when the process is running, we go back to the ready state. If there is some input output requirement or some other sort of dependency, it is put in the waiting state until that event is completed, then it goes back finally to the ready state. Again, the scheduler will assign it to the running state, to a processor. It is in the running state. Once the process has completed execution, it goes to the terminated state. So this is the life cycle of a process in terms of the 5 states it can be in.